Yo, what's up? Good morning. Okay, let's see where we left off. We're currently in the process of taking our tessellation solution and applying it to our current environment shaders, pretty much. And in that process, we are refining terrain base and terrain patch once again, but like refine. So the idea is that terrain base creates a material, and then when we create terrain patches, we call set material here, which will copy the material in question, add its own data to it, and then apply that material to the mesh renderer. And I'm gonna be so bold to allow for, I wonder, if this is even possible. We can try it. Wonder if we might need to do something special here. Maybe we will have to do we might need to do some special stuff here, I reckon, but we will see. Pretty much want to draw the same mesh X number of times, but with different materials. So same mesh multiple times, different materials. So it's not the same mesh, same material multiple times. We will see materials. Like, I wonder what happens if you just stack materials, and then we have different displacements and stuff like that. Okay. Don't we have... list, that's pretty good. We could probably do... Actually, let's try this by doing... Let's create our ground material, and then we can see what happens. Lastly here, mesh renderer. We're just gonna do this for now. Material is equal to material. So just one material. And let's see what we have here. Terrain material, water material. We're gonna change this one to ground material. Yeah, we want to set some of these, but I wonder... we want to set mesh dimension, mesh resolution, and mesh subquad diagonal, pretty much. So it's a little bit different this time around. Terrain data value range might be... Don't we have this one here? No, we don't. But I wonder if I wonder if I want to keep this in data specific values. So i.e. when we return this, I wonder if I want to do it here. So this one returns not a normalized height, but a absolute height, so to speak. We can wait with that one for a little bit. So what did we? Yeah, we needed these three. Then when we create it, we figure out most of the things here. Awake, subdivision, yeah. What do we actually calculate in generate? Bounce, delta. This one might... Yeah, we still need these two. Bug material, we're gonna wait with that one. I wonder though, let's take terrain ground, mesh dimension, we do it as vector, this one is float. Set vector, mesh dimension. And it's dimension subdivided we want here. Mesh resolution, I'm pretty sure. And the diagonal, let's just take the calculation we do here. Subquad size, number of subquads. Size, whatever number of subquads. Don't we create this one here? Or do we do it in generate? Subdivision. Oh, it's actually subdivision. Good morning, Geralt. And we have subquad size. It's just dimension subdivided, isn't it? Set float. I reckon, okay, something like this. And then we create the terrain patches, we set neighbors as well, and then we generate them. And when we have generated them, I want to do terrain patch dot set material ground material, something like this. And let's take a look at the ground material, the current one. So it should just be a subdivision. We don't really do anything here. Yeah, so let's see if we can render this at this point. Terrain, yeah. Weather effect, yeah, we're gonna work this one a bit, so we might as well. Environment, what do we have? Ground material rate. Something like that. Then we do environment. Okay, let's see if the computer can manage. Okay, it's pretty good. We have this one here. We don't offset by height anymore. So what I want to try here is ground material. Yeah, we don't subdivide that much, no. Yeah, we need to fix that one as well. Okay, so what I want to try here is we're actually gonna do... Let's do... terrain ground. Let's duplicate that one. Terrain snow. Like that, and then I just want to do input.position vs.y plus equals to 1.0 f maybe. We offset it in the y for snow, just 1. And let's create a terrain ground or a terrain snow material. I just want to see what happens if we stack materials for the same mesh. Terrain snow. And then yeah, let's take this rain patch, mesh renderer. We have it here. We add one. We get a warning. Two systems which costs performance. Is it using multiple shader passes? Yeah, we'll take a look at that eventually as well. Rain snow material. Does it actually work? Yeah, but I wonder how performance... So we rendered the same mesh twice. In this case, it might not cost performance. Or actually, I don't know. So we have terrain, snow materials. We can stack it like this. It depends on if it destroys our performance. Where do we have it? Over here. I don't want to select anything. We can hide this one. Maybe we can go with this. We can definitely go with this solution for now. Might wanna... let's see here. Pretty sure we can find out, or we can find a better way to do this. I think. But I mean, this is pretty cool. Spike indeed. Okay, I guess it's okay. Okay, good to know, good to know. Gonna have to do some research on material stacking, but this is pretty cool. So we just create one mesh. Every terrain patch uses that mesh for as many terrain effects it wants. So by default, each terrain patch is just gonna have, it's gonna use it for, actually, I wonder how rough it will be. So we have ground, grass, snow, water. It's pretty rough. We can stress test it. Eventually. But one thing that bothers me is, okay, so we have ground material now. Terrain base. We set the ground material. Terrain base, where do we have it? Here. We generate... Oh yeah, we generate the data accordingly. It's just that we don't use it in terrain ground. So what I would like to do here is Terrain ground. Yeah, plus equals to whatever. Terrain. We're just gonna do this for now. Terrain ground. So what we want to do here is, when we transform this one, we want to utilize this. I wonder about this one. Like, so yeah, like I mentioned, this is a normalized value. So somewhere we have to transform it to world space or something. I'm just wondering where. Like, we need to set it. So what I'm wondering here is if, yeah, it's probably a good idea to send down, if we go to terrain base, we have a nice, we have bounds here, probably terrain data value range. That's not the bounds. I'm gonna look for terrain data value range. Might as well send in this one actually. Wonder if I want to tie this to the different data types instead. But it also, it's pretty nice to have it here. But terrain patch, terrain data value range. terrain point uses it. To something like this. These are two options I'm thinking about instead of having it like this. I don't really see a reason to keep it in both terrain base and terrain patch. But then I also wonder if we do different values. So pretty much what it is that we store our height data, for instance, in values between 0 and 1, a float between 0 and 1. And this range just takes a value from 0 to 1 to that range. So we pretty much define the minimum world space height and the maximum world space height for the terrain. I'm wondering if we probably want to have separate, like, do we want a range for height and a unique range for foliage? Yeah, probably yes. But we can put it like this for now, and then we will work with what we have. So terrain data value range, I need to send this one down, and we're gonna private post string and then we set this one here as well. Terrain ground shader. Let's add it here somewhere. If we store it per container, we will also clean it up a bit. So if we store it per container, that value will be set here. We will store it here, and before we return, so terrain base data will already have, it will be transformed into a world space value instead of having to do it here. Because right now we're pretty much gonna have to do input.position bs.y is equal to, then we can do it like this. Terrain base data get terrain base data by input.uv 0. So this right here, this will be moved to the different terrain data utility files. Okay, but something like this, I think we set the data correctly, and we should see some offset on our terrain now again. Terrain base, data terrain ground. Yeah, we need to include it as well. Shader utils, terrain data. Okay, lerp, let's do. Okay, no offset. Our collider works. Okay, so that's weird. We set this one. All of this works. Generate. Yeah, this is where we create height collider, and here we send down terrain data value range and height. Height collider has the data. Our GPU might not have the data, maybe. So we do generate new container. If it contains height, generate values, and then we apply it. So apply, texture apply. Oh, did I forget? Set material properties, set texture shader property name, texture. Scale UV offset. Don't we set UV scale and UV offset? Ooh, yeah, we do. Okay, I just want to see if terrain ground. Let's see. Okay, that explains it. Oh, yeah. The fuck? Of course. Because... Stop this one. This UV scaling, it's actually... What's up, Ryan? The UV scaling is handled by the terrain data, so we have them... Here we have UV scale, UV offset, UV step, and then we scale them by that. When we do rescale here. So, the template is a bit wrong. What we want to do is transform UV try this. We have some UVs at least. They look pretty good. XZ. Yeah, they do. We're still not reading the correct data, right? So one problem fixed. Terrain-based data. Terrain-based data. Oh, macro type. Nah, that should be okay as well. Set material, vanilla type dependencies. Yes, of course. So when we do set material, we have to tell the method what kind of dependencies this material has, and we can do it like this. So this one, for instance, only has height currently, but we could add more here if we wanted to. Now we tell it this material is dependent on height data, and then the terrain patch links it accordingly, and stuff like that. Yeah, it has to be this one. Okay, beautiful. Do we have some weird... Okay, this culling we might want to fix eventually. Okay, we have some problems here still. Wonder why. Oh, no. The problem we're seeing is that our... Oh, can I do this? Yeah, we don't tessellate it as much. So if we take this one and we go to the tessellation, ground material, and we check. Let's tessellate it, I think 6 times. Is the maximum 7? Yeah, 6 times. Then we have a perfect alignment. Beautiful. Yes. Okay, so our selection currently doesn't work with deforming stuff. We have to work on that one. I think it's okay. Fix that one eventually as well. Okay. Where do we have terrain, ground material? Let's bring this one up to 6. Environment, subdivision constant, resolution. Oh, what's up? Data resolution 131. It's a little bit too... so what do we have? 128, 256, 9. Yeah, let's bring it up a notch, see what we have. As for the collider, however, we might want to pull it down a bit, but... Definitely have to fix this. The bounds are a little bit weird. We'll work on that. Are we at 256? Don't we have collider here somewhere? Composite circle. Collider. Is this actually 256? Wonder. Zero. 3. Or 4. 7. Probably is. Okay, but what is up with this culling here? You frustum. Back face. Okay, don't we calculate that one? That's weird. Let's take a look at this one. Back face tolerance. Stage tessellation, back face culling. Have this one. We get normal in world space. View direction world space. Do we calculate this one? View vector. I wonder what we do with normal world space. Yes, when we create this one mesh builder, oh, I left behind the previous session. Do you mean you left before it was finished? Do you use input system? Yeah, I actually used a new input system. No complaints so far. It's pretty good. We recalculate normals and we recalculate tangents and we recalculate bounds here. The bounds might fuck us a bit, but that's not... No, that's not at all the culling we're currently seeing. Something is wrong here. Should backface cull... Dot normal vs view direction vs. What the hell would we see? Oh yeah. Okay, I wonder if relying on recalculate normals and recalculate tangents for when we have mesh topology quads might not be the best thing. So recalculate bounds is also... we're gonna have to redo this one a bit. So we're pretty much creating a flat initial mesh. So the bounds here will be extremely conservative. They won't... Yeah, they won't work at all with our displaced shader. But let's focus on these two and see if that's what we're doing wrong. And I always forget. Let's do vector 3 normals. Now we have vector 4 tangent. And we're just gonna do normals, yes, is equal to like this and tangent j times I think we want to do it in the x direction, but I'm not sure. And then we have the fourth coordinate, which is -1 or 1 depending on tangents. Can we see here? Yes. Along the horizontal u, so positive x, I would say. Yeah. Use to flip the binormal if needed. Yes. Unit calculates the between normal and tangent. Tangent v, therefore should always be 1 or -1. I think it's... Oops. Actually, we take the cross product between normal and tangent and multiplying the result with w. So I think it should be 1. But if I remember correctly, I think here is the old one. Where do we have tangent? For some reason I did -1 here. Platform specific C83. For all you make terrain, yes sir. We're gonna go with 1. Let's see how it looks. So we do 1 here. Set indices, topology. Call it tangent. See if we get what we want. So it's the... Okay, we don't have... Okay, we don't cull this time around, that's good. I want to see what happens if we bring down... back face frustum. That's pretty good. Okay, that's not good. But this one... I wonder if this has to do with bounds. Yes, it has. Problem is... Sure. Yeah. If we use the same mesh, however, wonder what we can do about the bounds. A mesh bounds should be an object space, right? Mesh unity. Bounding volume of the mesh in its own space. That's beautiful. The bounds don't change if you change the... Yes. Okay. Perfect. So. We should be able to set in terrain base. We want to set the proper bounds for the submesh. Here we create it. Now we do base mesh dot bounds is equal to new bounds. What kind of constructor do we have? Center and size. Center and size, you say? Like, I'm pretty sure we have done this, or that we do this somewhere. We just have to move where we do it, pretty much. We have bounds here. Patch bounds, that's not the one I want. I think we have it. Bounds. Transform position. Plus terrain data value. Position. Yeah. But we want it in local space, don't we? And this is not it. Yo, what's up, Spires? Hope you had a wonderful stream. You too. Okay, we want to create bounds in local space, so it's not these bounds. But instead it's... So the center, where do we have it? The center should probably be, I hope it's in local space, vector 3.0 plus, we want to offset it on the y-axis, and here we're gonna use data range, data value, terrain data value range. Farrell, what time are you live on YouTube? What time zone am I in right now? Let me just double check real quick. I go live every weekday 9 a.m. GMT plus 2 currently, I think. Maybe UTC plus 1. Is that correct? But like, I always notify on my Discord, so joining my Discord is probably the best way. So every time I go live, I notify on Discord. If I for some reason isn't able to stream, I also notify that on Discord. So what I want to do here is, it's in local space. Okay, I think it's just 0 here actually, and then bounds. And for also for you, 5 in the afternoon. That's pretty good time. So for the size, we want to do X should be dimension subdivided, I guess. Y should be rain data value range dot max. Am I thinking about this? No. We want to do range dot lerp 0. No, that's not true. Let's go with max for now. Something like this, base mesh bounds. Let's see if we get the same weird culling if we do the bounds. This. So the culling we get are when we look at it like this, and we don't get it right now. Hopefully it should be culled behind us here. I guess we're gonna have to figure out how to check that, but this is good. A bit. Yeah, we have to be real far away. Oh, is that so? Oh, yeah. Okay, that's good. Ooh, that's good. It's real good. A little bit too liberal with the tessellation, I reckon. But if I will use Unity 2022, now I used to be on 21.2, but at the beginning of, fuck, was it this year? Time moves extremely quick these days. At the beginning of this year, I actually migrated my project to Unity 6. I wonder why we are this. So if we take a look at the tessellation here, it's a little bit too... Tessellation distance bounds, let's go 20. Actually, let's do it like 200. Don't we change anything here? No, we don't. Let's take a look at distance bounds. Or actually, let's take a look at the tessellation implementation. Stage tessellation. Nearest point on quad. Calculate tessellation. We have to be careful with this one. Distance, length. Mesh subquad diagonal. I'm not entirely sure we calculate this one the correct way. Let's take a look. What do we have here? Mesh subquad diagonal length 90. So that's this full one. Yes, that's wrong. Mesh dimension 64, 64. Environment, yeah, dimension 256, and then we split it into 4 subquads. Yeah, that's 64, all right. So each terrain patch here actually gets split up into its own subquads as well. So for this one we have 3 times 3, but when we calculate the tessellation we actually use, so when we calculate mesh subquad diagonal length, we use the full quad. I would like to use the subquads here. So that would be terrain base. When we set this one, dimension subdivided, yeah, that's not entirely true. Is it? PG King, hello, hello, hello. What's up, what's up? Yeah, mesh dimension, mesh subquad diagonal. So what we want to do is, where do we have our test quad? Mesh subquad size. We do size divided by number of subquads. We need to calculate this one. No, we need to calculate this one. Dimension subdivided. Let's jump to this one. Dimension subdivided. It's resolution. Yeah, so we want to do dimension subdivided divided by base mesh resolution. Pretty sure this is what we want to do. Can we make this look a little bit nicer? Yes, we can do base mesh resolution, load, base mesh subquad size. Can we fit it on one line? I don't. Okay, let's see if this fixes it. I think this is much better. yes. Although now it might be a bit too... The fuck? Really? And now we're back at not fixing our... okay, that's weird. That's weird as hell. So what do we have here? Base mesh subquad size. What do we have here now? We have 22, roughly. Do 56 divided by 4, and divided by 3, and then we do to the power of 2 times 2 square root 30. Yes, because I think we want -1 here, don't we? Subquad size number of subquads. Number of subquads. And that's very important because I think mesh builder resolution, yes, that's the number of vertices. So in terrain base, when we do base mesh subquad size, we remove 1 here. That should hopefully solve it. No. Okay. Yeah, but let me just check this one. What do we have now? 30, 16, that's what we have. Okay, I think that calculation is correct now. It's just the fact that we don't get a split here, which I find to be extremely weird. Terrain base data. No. Terrain ground shader. We do use stage geometry. For all, goodbye, thank you for stopping by. Appreciate it. this fix again. I'm growing a bit tired of this one. So what do we have? Mesh. Want to see if this one. Undeclared identifier. Equal to 30.16. That doesn't matter. So once again, it's this one right here. This one. This one. Rain ground. Burn. Dot seam. Oh, okay, we do get a seam here. Interesting. Yes, could it be? Mesh dimension, mesh resolution, resolution subdivided, yes. I fucking wonder. Now we want this one to be the full. 64, 64, 128, 128. Yes. It's data resolution we want to base this one on, I think. Yeah. Base mesh resolution -1. I wonder about this one. Now mesh resolution is actually 2 to the power of this one. Ooh. Yeah, it's a number of subquads, so it should be this, I reckon. But now we're sending down data again to the GPU, so we need to restart this. There we go, that is correct. Okay, good. Nice to know that it was only the properties we sent down that were wrong. And nothing with the calculation itself. Okay, so then we can continue. Like, one thing I'm not looking forward to at all is we're gonna have to check so that UV scale and UV offset is correct, because basically I'm trying a new thing here. Since we're calculating the normals on the GPU, we need, so at the edges we need some additional data. So I pad my data with, we pad the data, the texture, with 1 in each dimension. So if we have a texture, a terrain texture that is 128 times 128, we pad 1 in each dimension. So we get 130 times 130. That fixes our normal calculations. And then we also pad with 1 more pixel because we want to align the vertices to be in the center of pixels. So it becomes 131 times 131. And then we have to set the UV scale and UV offset to take these into account. But when we generate the initial Perlin noise, we also need to take this into account. But yeah, we'll see. Fuck, now when I think about it. I wonder if we want to do that here. So if we scale and offset the UVs, yeah, if we scale and offset the UVs for the ground material here, that fixes all of our issues, I think. Generate index vector 1. Generate values. Maybe not. No, because here we do it like this. unfortunate. But. Should be able to send in just this, I think. UV offset, UV scale. It's fucking beautiful. So terrain data container, generate values. Generator. UV offset. Yeah, we're gonna have to do some weird index calculations here. And we can probably solve it. So data container actually has these values. So I think when we generate values, we can just offset the scale and stuff here, I wonder. Probably. Let's test it. Terrain ground. Okay, let's make this a tiny bit more beautiful. Normal vs color. I'm gonna do normal vs. We want to include shader utils, util normal. Or is it normals? Normals. And then we want to calculate Calculate from texture diagonal, I think. But. I think we're gonna do this. But if we're gonna do this, we need step in world space and height in world space. So then we're back at this one. Do we have a best case scenario? We would have this, or we would have data inside of this one, enough data to deduce step world space. I don't think we do. In terrain ground, what do we have here? We have UV, these we don't use anymore. And then we have terrain data value range. So we don't have any information right now to deduce world space step. Actually, mesh dimension. We do mesh dimension, mesh resolution. Mesh dimension. Hell yeah, we're gonna use this one. So I wonder... We're gonna do... It's a float 2, right? So we're gonna do one of these. Oh, we actually have them here. Mesh. Yeah, but that's... we need... So in utility terrain data, I'm gonna do one of these. If it's not defined, we do it like this. And now we have all the information we need here. So we could actually calculate this. Okay, this is quite nice. I'm thinking... Let's go to util normals and... What's the difference between this one? Okay, I'm thinking about doing something like this. Let's see here. I would like to get the binormal and tangent, but if we're doing all of these, we might as well do these. It's always best to... Oof. Best case scenario, we would probably do... Like, honestly, calculating the normal and store it in a texture is probably the way to go. So every time we change the height map, we recalculate the normal and then we just read one value instead of having to calculate this at all times. What about the tangent? And yeah. Let's go with this one for now. We can worry about that one later. Because I'm thinking about doing... Step UV, probably want to float 2 step UV. This one I'm a little bit worried about as well. But no. Then we're gonna have a... What I'm thinking about here is to finally get rid of terrain base. Have it in data value range bounds. Yeah, this one we don't use anymore. This one we can wait with as well. Oh, this is gonna be so much better. Improve so it's not tied to. That's fucking beautiful. Value normalized. I think we can get rid of this one. Instead, we have bounds here, which we terrain data value range max 2 times. Yes, okay. We're gonna do this. Joink. We have dump dimension here. Actual 3 dimension. Actually, let me just double check what value we had. Yeah. Dimension 256. I'm gonna do it like this. I'm always impressed with how you manage to separate what needs to be done in small-ish functions and then in its own files. Yeah, I try. Appreciate it. This rework here, however. Do we use this one? No, we don't. I should really have made a cleanup here a little bit earlier, but I guess this is okay as well. Dimension subdivided. So, dimension subdivided, I'm thinking about changing this one to 3 as well. And then we have bounds here. We don't need this one anymore. We're gonna rely on dimension. Solution. We can get rid of this one. We'll see. Yes, so here we want to do... let's fix these first. Dimension subdivided. Dimension subdivision. And then we'll do base mesh sub quad size. Base mesh resolution. Here we take .x. Actually, what we want to do here then is... now we want to separate it. So this one is going to be equal to 2 times... really? 2 times this times this, but with y here. Okay, we need 1 more here and 1 more here. And we need 2 more here. Base mesh bounds. Yeah, this one dimension subdivided dot x dot z. Ooh, dimension subdivided should be z here. Range data value range. Yeah, we don't have this one anymore. Instead, we do dimension dot y. But this is the center. So like when we define bounds, we do it by center and size. So we're gonna have to do we're gonna have to offset this one a tiny bit. Fuck are we? Yeah, we're at the bottom right now, so we're gonna, yeah, plus dimension, or 0.5 times dimension y times $3. There we go. Ground material mesh dimension, dimension subdivided. Here we just change these to x and z. And terrain data value range, this one we don't want to use anymore. On draw gizmos, bounds. Don't I store? Don't we store this one? Can we draw it by something else? Draw wire cube, yes, center and size. So we're just gonna draw this one again. Okay, so generate, like Delta, delta, delta. Terrain projection matrix. Yes. Makes me wonder if what the hell, we can do this as well. Base mesh, bounce, 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 bounce. So here we can just draw a wire cube, base mesh. No, never mind. And this one should be dimension X and dimension Z, so we can just do dimension. So, like, I'm wondering, I don't think we need to keep all of this shit around. Dimension subdivided, data resolution. We don't. Data resolution subdivided. Okay, ortho, left, right, bottom, top, near. Yes, dimension subdivided plus delta. So this resolution subdivided is wrong this time around, so base mesh. It's pretty much these values we want to keep around. or these, the ones we set here. So we're gonna do mesh dimension, mesh resolution. But that's base resolution. And then we have subquad diagonal. Yeah. So the way we're gonna do it here is it feels like I have to finally decide on exactly how I want this setup to be made. I know that it's been a lot of back and forth concerning this one. But it's pretty much, we definitely want to define the full dimension of the whole terrain. And we want to define the resolution per terrain patch, pretty much. So that's... So this one and this one. So we need some better terminology here. The resolution subdivided, that's deprecated. So because now initially we created, like when we created the terrain patch mesh, we actually subdivided it fully. But now we're gonna subdivide it a lot on the GPU. So what we tell it here is pretty much... Okay, so we have something like this. We have a terrain base that subdivides a full terrain into patches, and each patch gets subdivided into mesh-like structures. Previously, all of this full pipeline was done on the CPU. The last step here now is going to be done on the GPU, so we just want to create a base mesh that will allow for subdivision. So data resolution, so it would be something like dimension subdivided. We can do, I think I want to do this. Serialize field, private vector to patch count. Maybe. And then we're gonna have patch resolution. We're gonna remove this one, we're gonna remove this one, we're gonna remove subdivision constant, subdivision delta, that noise scale, ground material, terrain activity, yes, debug settings, test flags. These are gonna take a lot of, or a tiny bit of rework as well. And then we have base mesh, terrain patches. Occupy terrain subsets. Yeah, whatever. Do we use this one? So what we want to do instead is dimension subdivided. We do, question is if we want dimension subdivided up here eventually, but we'll see. Dimension subdivided, it's going to be a vector 3. It's going to be equal to dimension x divided by patch count dot x, dimension dot y, and dimension dot z divided by patch count dot y. Resolution subdivided, we don't need to calculate this one. Then we have base mesh resolution. So here we take not data resolution, but patch resolution. -3 log 2 -6. This one right here. So we pretty much, this defines how big our data will be, our data textures or compute buffers. And then we want to decimate it to a point that we let the GPU tessellate the last parts pretty much. So we remove 6 here because that's the maximum amount of tessellations we can do on the GPU. And then we also remove, we do log, and then we remove 3 here for the padding. Then we create this one, dimension subdivided. Actually, this one, we're gonna call this one patch mention. Base mesh solution. Yes. And then we have bounds. So here we just need to do patch dimension. A little bit cleaner. And then we have this shit. So mesh dimension. Do this as a vector 2. Okay, with that patch dimension x, patch dimension z. Then we set vector mesh resolution. And we want base mesh resolution here. And then a mesh subquad diagonal, dimension subdivided, patch dimension, base mesh resolution. It's a little bit clearer, I would say. So now my question is, which of these do we need down here eventually? So delta, dimension subdivided. Why do we need delta here? We need delta for this one. Do a final. I don't care about this one. Bounds here. which I just think is base mesh dot bounds dot size. Okay, projection matrix. Patch. Yeah, we don't have this one here, so we need this one. So patch dimension, this one we might want to do this. Patch count, patch resolution, private, patch. Delta, we're gonna have to worry about this one soon enough. Left, right, bottom, top, set, near, yeah. Left, right. That's not true. Dead. And then we have the delta. It's actually our offset, I think. Or not really. We're gonna have to... I'm gonna take a look at this one eventually. Rain patches, and here we do patch count.x, patch count.y, I thought. Just subdivided patch dimension.x. Dimension.x said. Okay, so the question now is, now it's up for terrain patches. We can check this one as well. Occupy entity terrain subset. Ah, okay. Okay, so let's see. Terrain patch. Dimension resolution. Our base mesh will have most of these, I reckon. Index. We still need index global. Yeah, we might want to have index global. I'm gonna be able to remove a few things here. But if we take a look at dimension, it's in 14 places. However, position object space. Dimension we don't need anymore. I'll show why soon. Resolution. I think we can get rid of this one as well. Because basically what this one did is it transforms a two-dimensional index to a one-dimensional index, but it's based on the fact that every data type has the same resolution. That might not be the case. So our height data might be 131 times 131. Our water data might be half that or double that. So I'm just gonna do this. Let's see. Index, I still want this one, I think. Get global index, that's not entirely true either. Might not. Solution. Let's keep index, delta, patch bounds. Going height multiplier, no. Terrain data value. Maybe move to data containers or keep only terrain base. That's what we're doing right now. Terrain data containers, we need neighbors. Honestly. I don't think we need this one anymore. Okay, if I manage this cleanup, it's gonna be fucking beautiful. Activity, texture, view matrix, this one we want. Entities we want. Mesh filter, mesh renderer, height collider. Okay, let's see. Has data. These are a little bit messy. Improve so it's not tied to terrain data value range. Beautiful. It's not gonna be soon. So data type value normalized. Is it just value? Data string. Index global, no. Position OS. index. Yeah, we're that's one sec. Might have been a bit too quick there. Or was I? No, I don't think so, because get information. We're gonna move this one to our terrain. Yep. Information provider. There's no reason for our terrain patch to be, or is there? All of these are gonna have their own resolution, like, or we want to build for that fact. I think we're gonna handle it in terrain base, actually. I'm a little bit worried about how much I change and delete, but version control can fix it. Get activity, render texture, clean up and obscure. Yeah, we're gonna do this eventually. Generate terraform data. Offset, patch, bounds. Bounds. Oops. So what I would like to do here is to offset. We have a dimension, but it's in. I think we're gonna do it like this. Public bounds. 2 bounds. Mesh filter dot mesh dot bounds. So here offset we just do bounds.x or size.x, bounds.size.z. This one is a bit, for some reason I put this as a range. Slurp. You know what? Terraform data is also gonna get... So, previously we did this on actual vertices. Right now Terraform is gonna be purely on the GPU. So... Yeah. Get index wrapped. We don't need these anymore. So these were for calculating the normal on the CPU terrain point, but whatever. Join, doink. Get terrain patch. We don't need this one anymore. Get terrain patch on safe. We don't need this one anymore. Nor this one. Like, we're offloading a lot of stuff from the CPU to the GPU. Set height multiplier. We're not going to do this anymore. Set neighbor. We don't care about neighbors anymore. Question mark? No, we don't. Set material, nice. This one is new, we want to leave this one. Okay, so what do we do here? Instantiate. We send in index, position. We only need to send in... I wonder about resolution though. Nah, I think we're gonna do it like this. So everything resolution based is going to be handled by the data container itself. And it's going to be controlled by the terrain data type. It's pretty much going to be like this. We want to rework this one eventually as well. Maybe we will do it this week, or next week. But it's pretty much going to be like this. First last increment as string is buffer timestamp dependent. Let's do public static int vector2 int resolution. And for now I'm just gonna do default return. So let's do 256 as our default. 256. So 256 plus padding plus pixel centering. So 9 times vector2 int. Can we do it like this? 1. Which means that we're actually gonna do this. Patch resolution and then we do patch resolution. We're gonna have a base. Let's just do terrain data type dot height resolution. This one is a vector 2 now, so we might need to do base mesh solution is equal to new vector 2 int base mesh resolution base mesh resolution dot x y dot x. So now we should be able to handle non-square terrain, but I don't even know if we need that or if we're ever gonna use it. So what did we have here? Index, index, index. I don't think we need index anymore, actually. Bam, 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 bam. New container resolution. Doot. Perle noise generator. That is true. We can just do what was index? Was it a vector 2 int? I think so. Or UV offset. New container. Okay, so this is nice. We don't need to send in width and height anymore because we're gonna do this. Vector to int resolution equal to type dot solution. But x, y. Like the more things we of these things we locate here, the better, I would say. We're gonna need a recompile if we wanna. We needed to restart the game anyway. Okay, new container. What do we have here? Height collider create. Okay, this one. Dimension. Rain data value range. Dimension we can send in. Don't we have resolution here? Oh, we do it with this beautiful dimension. So we're just gonna do dimension. And we have this one here. Rain patch. Bounce. Bounce dot size. You can just send in bounce. Terrain data value range, we don't need to send this one in anymore because we're going to use it from the data. Bounce. And we'll get to that one soon. Haven't fixed this one just yet. Rain data type. So this is where we're gonna have it. We're just gonna do it like this. Resolution. Public static. Do I want to use range? Maybe I do. This one is growing to be way too complicated for this enum architecture or whatever. And I have something in mind that I really want to try and implement. Not right now. Default, new range, and we're gonna go with 0 and 10 by default. So here we just do not value normalized, but let's see, terrain data container, alter value, set value, clear, value normalized value. We have this one as a byte. We're gonna have to work with this a bit as well. Value byte, value normalized, and then float value. can we store them as bytes here? I'm not too sure about this one actually. Or am I? Byte. Yes, okay, I am. Slurp. Value normalized. Okay, so where were we? Height collider. So what we do here instead is we just take data dot value. And the data itself knows the range. Right now, every type of data has the same range. This is beautiful. Okay. So back to terrain patch. Don't we have any more errors here? Feels like we should have a bunch. Swap terrain data. Stop all terrain data. We're gonna have some errors in the fluid sim. A few. Util normals. Yeah. Terrain base. Weather effect, yes. Is mesh dependent. So this, like previously when we had weather effects like this, it was pretty damn complicated because some weather effects like snow, for instance, would need to add or generate a new mesh, position it, etc, etc, etc. But this time around, weather handler, we're pretty much just gonna set a material. So generate mesh, we don't need this one. Apply to terrain. Look at all this. It's weird as hell. So right now instead, oh, this is gonna be so easy. Apply to terrain. I think all we need to do now with these changes is see here, weather effect type. We're gonna display name, type name, memory value range, dependencies, terrain data dependencies. This we still need. But let's see here, mesh. No, environment. No. So we just do this. Dependencies, descriptor values. I'm gonna do it like this. Field, serialize field, public, material, and we're gonna call this terrain material. And terrain data type dependencies. We're gonna do terrain material data type dependencies. And then in weather effect, all we need to do is if yeah, we don't need this one anymore either. Instantiate objects, we don't need this. Mesh, we don't need this. Affected terrain patches. No. So we just check if type dot terrain material is not equal to null. If so, then we just need to do terrain patch dot set material original material. We set type dot terrain material, and on dependencies type dot dependencies. And that's everything we need to do now. So if we have our terrain, we want to add a layer of snow on all of it. This is just what we need to do. We don't need to generate a new mesh, position it, keep track of rain patches and whatnot. Later on we might have weather effects that alters properties on materials, so that might screw it up a bit, but wind texture, yeah, we need to rework that one as well. Terrain base, okay, so this is beautiful, I think. Let's see. Position, terrain patches ij, set parent, instantiate. Terrain patch. We're probably gonna have to do some debugging eventually, but instantiate, we don't need index, we don't need dimension, resolution, or terrain. We just need to send in base mesh. This is everything we do with instantiation. Position and base mesh. Then we set layer. We don't need to set neighbors, so this is beautiful. And then we do terrain patches ij. Since we don't set neighbors, we don't need to instantiate neighbors before we do this stuff. So here we're just gonna tell it to we need UV offset here as well. So we generate it, we instantiate it, we generate it, and set layer. And then we do set material as well. Yeah, this one is if we want to clear it. Set render target, clear render target. Yeah, we might want to do this eventually. But we're going to do it like this. So we can remove all of this. And then on terrain patch generate. If it contains this one here, we load the data, but we also want to do flag to enable load. If not, load clear texture. Wonder if I will understand this one in a couple of days. We'll see, we'll see. Okay, great. What more errors do we have? Normal data. Terrain patch does not contain UV. Yes, okay, so terrain point, terrain subset, terrain point, terrain fluid solver. I'm gonna have to do a little bit of a rework on that one as well. So I wonder. Let's just go through it real quick and see if we can. This is terrain fluid solver. So to rework this one a tiny bit. Finish step position. Terrain point. So I would like to take a step upwards when we fix this fluid solver. So previously it worked, so we defined terrain points, which is, we defined a lot of structs here. What I would like to do is eventually I would like this fluid solver to work on the terrain base and then let terrain base solve the recalculations. So the fluid solver, it doesn't know, it shouldn't know anything about terrain patches or stuff like that. The only thing it should know is point coordinate, in a global point coordinate, and then it send down that to the terrain base, and terrain base gives it everything it needs. With a solution like this terrain fluid solver, it currently worked pretty good, but it had some problems at terrain patch edges, and like taking a step upwards and do the approach where we talk to terrain base instead is gonna make it possible for us to fix those edge artifacts. But I don't want to do that today. No, 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 no. So for now, game of creep. Ooh, get this one. Sphere. Let's just comment this one out. So terrain point index global. So right, previously it had a reference to its terrain patch. It was messy. We used index global like this, so each terrain patch needed to know about their neighbors to calculate their global index and a lot of stuff like that. I don't like that at all. We work with position OS instead of indices. Yeah, fuck terrain point. So we're gonna work this one. I don't know if we want it like this. Maybe. Or actually, best case scenario would be to do it on the GPU. Fairly. Maybe I should take that step. That would be very cool. Would be extremely cool. Yeah, I'm gonna have to think about this one a bit. For now, I just want to fix it so that we don't have any errors concerning it, at least. So it's terrain point. Redefinition of mesh dimension. Thought we added the correct, so mesh dimension. If not defined, define. The fuck can it be a redefinition if we tell the compiler to not redefine if it's already defined? Huh. Probably missing something. I guess it's this one. Okay, so this works. Ah, could it be? Could it be? Could it be? Terrain, ground, color. What do you mean redefinition? If it's not defined, define it. Otherwise, don't. Can't we? Nah, we should be able to do this, right? Terrain data value range, we're gonna remove this one as well. Maybe we cannot do it like this. Yeah, we can't do it like this. Oh, fuck, it was my mistake, my mistake. We need to do it like mesh mention. This. That should fix it, I hope. Yes, beautiful. We had some truncation stuff here I'm a little bit worried about. But whatever. Okay. Terraform the terrain base does. Delta offset, yeah. Yeah, we're gonna have to look into this one as well. Okay, we've done a lot of changes here. Most likely nothing will work. But let's try it. Yeah. Tempted to divide by 0. Okay. Yes. Bounce. We do this in a little bit of a, we don't need to do it like this. Terrain subset. All we need to do is we just want to find which terrain patches this entity overlaps with. We can probably do it with some sort of physics stuff. I wonder if can do this in a way. Can we? We can simplify it a lot. We need this to happen quickly. Subset. It's easy. We just need to do int I is equal to 0. Let's see here. I is equal to mathf floor to int entity bounds dot min dot x divided by no, we need an offset here as well. Read offset. Blah, 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 blah. We can do it like this. Entity dot bounds dot x plus min dot x plus 0.5 f times dimension dot x divided by patch count. No, that's not true. Patch dimension.x. And then we take this and do mathf floor to int. think we want to do minus here. Or no, no, no. Plus y, and seal to int, and then we just do entities.add. Okay. Index was out of bounds. Okay, okay. Yeah. So we want to go sed here instead. Really? Is it the offset I'm screwing up? Oh, yeah. This isn't local. No, it's not. So if we have one positioned at 0, 0, 0. Yeah, it's negative dimension, is that it? But yeah, that doesn't really make sense, does it? We want to do it like this, I think. Can do it like that. If we take this one, have bounds here, do we draw gizmo, draw wire circle dimension? Oh yeah. It's way better to just do it like this. Yeah, let's store this one. It might be good to have. Then we do see, I want to do something like inverse mathf inverse lerp brain bounds dot min dot x brain bounds dot max dot x entity bounds min dot x, and then we multiply this with dimension dot x and then floor to int. Not really. Inverse lerp. Something like this. Looks a bit rough. What parentheses are we talking about? Are we talking about this one? I want it. Yeah, this feels... Let's see, doesn't bounds have a method like this? Bounds, we check if it works first of all. Int x min. So we calculate the entity's position in relation to the full terrain, and we calculate what patch it's located at. And we add those. Something like that. What the fuck, we don't need to do it like this. We don't need to divide here. I don't think. Instead, we should be able to just do times rain patches dot size or length. Now we shouldn't be able to get outside the array bounds, at least. I don't think. I don't hope. That's crazy. Yeah, I know why. Okay, if we get outside of it now, it's time to call it. It's time to call it soon anyway, but... Okay, beautiful. Nice. Environment, dimension, 100. And 100. Patch count. 10, so each patch is 10 meters. Terrain bounds, center extends. Terrain bounds, oh yeah. Let's make this private. Base mesh. Private. Am I doing something bad? Okay. Yeah, we have way too many. One sec, new game object. Okay, we created way too many patches, do we? Or no, maybe not. No, we don't. Okay. 3 each. Maybe this is a bit overkill. Don't we have a mesh collider? Mesh collider. Okay. What did I do to possibly screw this one up? You know, hey, just dropping by to say that I love your videos. Thank you, appreciate it. I came across it a couple of days ago. Very high quality devlogs. Thank you, appreciate it. Been a while now. But hopefully I will soon be able to release more. Okay, so when we create our meshes the correct way, but our collider mesh got screwed up. So, you know, I'm currently a solo game dev, but also working on some projects with some friends. Sounds nice. So when we initialize our height collider create data terrain data type height. How did I manage to screw this one up? Ooh. Didn't we rename this one? Value byte. Oh, that explains it. Value. So, you know, is this terrain generation? Yeah, we're trying to clean up the... Or we have recently added a big update to the underlying system. Now I'm just trying to get it to run again. Value byte. Okay. Let's try this. Data. This is what we want, I think. Okay, environment. I wonder. Let's go with 4. Let's generate it quickly this time around. Or quicker. Oh, that's better. 256, that's a bit much maybe. Actually, no. Okay, so everything works except for the fact that we don't get a height on the terrain again, and I know why. So we moved that's a lot of triangles. Yeah, we're tessellating it quite a lot. But so we moved. Where do we have it? Terrain base data. We moved the real height here to create terrain base data to this one, so we also need to send it down. But unfortunately I won't have time to do that today. We're gonna get to it tomorrow. Hopefully I will remember the problem. And as to the triangles, let's see. Scene. We can disable. So like if we take a look at one terrain patch here, yeah, there's a lot of triangles, but we have some dynamic tessellation going on. So the base mesh is actually just, what is it? 4 times 9 triangles. Not even that actually. It's 9 times 2, 18. And yeah, when we're really close to it, we want it to be extremely detailed. I'm assuming you're making it so you can manipulate the terrain. Hell yeah. We actually had a pretty... So, like, we had a lot of things in place, but then I choose to improve upon the... or optimize the renderization and tessellation of it. And now we're just trying to get back to where we were. So yeah, you're gonna be able to heighten it and lower it and add water, add grass. A lot of stuff. Eventually. But yeah, unfortunately I don't have more time today, so we're gonna continue this fix tomorrow. Yeah, I just want to say thank you so much for watching, everybody. I appreciate it, and have a great rest of the day. Peace.